The goal of this research is to look at various dual-pole radar signatures to look at whether dual-pole data might be helpful in predicting QLCS mesovortices. And the motivation for our work is that QLCS events are obviously challenging. As can be seen in this animation here, there are several mesovortices that form and dissipate quite quickly. And then, of course, the longest-lived mesovortex of them all is actually a non-tornadic mesovortex. So really, we're just looking for any type of tool that might be able to provide some information about the characteristics of these mesovortices. So we're going to step through each of these key takeaways one by one. For the analysis that we've done thus far, that includes 120 mesovortices across 13 different states. There's also a QR code that you can scan that will take you to a semi-interactive presentation with more information. So we're going to start off with a low-level signature that we see at 0.5 degree elevation angle called a KdP drop. And it's just an area of lower KdP that develops on the backside of the main convective line. It's similar in its idea and location to the Z-drop within the 3 ingredients method framework, but it might be a little bit easier to see and use in real-time operations. 95% of the mesovortices that we looked at were preceded by one of these KdP drops, and the mesovortices tended to develop on the left side of the KdP drop. So we just divided the signature in half and saw which side it developed on. And you can see that a pretty big majority of mesovortices form on the left side of a KdP drop close to the low-level KdP core, which we'll talk about here in a minute. So it could give an idea of where a mesovortex is about to develop. With KdP cores, a KdP core is an area of 1 or greater degree per kilometer KdP, typically near and below the environmental melting layer. So we looked at mid-level cores, which is close to the melting layer, and then low-level cores, which is at 0.5 degree elevation angle. And for both low-level and mid-level KdP cores, we saw pretty big differences between the max KdP observed in the signature of the tornadic and non-tornadic mesovortices. And you can see that the results are statistically significant for each mid-level and low-level KdP cores. We also can see that KdP cores tend to be stronger as we get higher EF scale rating with the tornadoes. So these KdP cores could be a decent signature to try to provide some idea about the potential strength and impacts of a mesovortex. In terms of ZDR columns and -20C reflectivity cores, ZDR column is just an area of 1 plus dB ZDR above the melting layer. And for both of these signatures, we did not see much in the way of differences between tornadic and non-tornadic mesovortices. The results were not statistically significantly different. There's lots of overlap there, so it might not provide a lot of information about whether a mesovortex is going to be tornadic or not. In addition, for the -20C reflectivity cores, we only observed those with 42% of the mesovortices. So really, I think that the 50 plus dBz threshold is just not ideal for QLCS events. A lower threshold might work better, but one way or the other, we didn't see those differences between the tornadic and non-tornadic mesovortices. So these two signatures might not be the best for QLCS events. The last signature is not dual pole, but it was interesting. It's a low-level area of enhanced spectrum width, which is typically co-located with the mesovortex. And for this, we did see statistically significant differences between the spectrum width of tornadic and non-tornadic mesovortices, but this signature does not develop before the mesovortex. So it's not a precursor signature, but it could give at least a little bit of extra information about whether a mesovortex might be tornadic or not. One other thing that I thought was interesting was we didn't see differences between the magnitude of the spectrum width within the signature and the EF scale ratings. And that points back to the KdP cores, where there were differences between the EF scale ratings. So I think that just gives a little extra evidence that those KdP cores might be some of the better signatures to use for QLCS events. So that's all that I have. I thank you for your time, and feel free to reach out with any questions.